Good morning, one and all present here. Myself, Dr. P. Janagaratnam, Assistant Professor, Department of Mechanical Engineering, SNS College of Technology. Today, I am going to discuss about the new topic, which is related to the velocity, acceleration, and how we are do the analysis by using the either graphical method, by using the relative velocity method, or analytical method. First of all, the rate of change of displacement with respect to time, which is called known as velocity. Displacement means the rate of change of distance with respect to time. So acceleration means the rate of change of velocity with respect to time, which is called known as accelerations. We can do any kind of mechanisms. We can do the velocity and acceleration based on their velocity and acceleration movement. We get the output. So today, elaborately, I am discussing about the how we are draw the velocity and acceleration diagram of different mechanisms by using this kind of graphical relative velocity method. Okay, so understanding the motions through graphs, why graphical analysis matters. So graph reviewable relationship means the position, velocity and acceleration over the time. And visualization of motion means decode the complex kinematics movements and real world applications and analyze a jet powered car motion. Can if we are moving the car means what are all the motions and what are all the positions and what are all the velocities may be occur during the running of car. So this and all we have to develop by using this kind of velocity acceleration methods. So the basic position versus the time graphs. So position means vertical axis and time means we have to take the position as vertical axis and time in that horizontal axis. So this interpreting the slope, velocity, the straight line which shows that the constant velocities, there is no variations in the velocities, and curved line which will be denoted as the acceleration. So if we are producing the straight line, which means the constant velocity, and we have to develop the slope means velocity, and the curved lines which will be denoted as the accelerations. So example, we have to take that jet car displacement graph showing this the steady motion. So from the position to the velocity, so deriving the velocity graphs, slope versus velocity, rise or run the target, and instantaneous velocity found by drawing tangent lines in the specific points, and average velocity, the slope between the two distinct points. So this is the general way we have to calculate this kind of velocities. So this is the velocity versus time graphs interpreting the motions during the dynamics. So velocity under the vertical axis and time which will be an horizontal axis. Here the slopes are area, slope which is denoted as the acceleration, horizontal lines which will be constant velocity, slope line accelerations or deceleration, maybe either increased or decreased. Area under the curve which will be an displacement. So acceleration from the velocity graphs, acceleration defined the rate of change of velocity over the time. Positive slope speeding up and negative slope slowing down, and curved graph which will indicate the changing of accelerations. If we are driving the car, if we are knowing that A, B, C, which means first one is for accelerations. We will give the acceleration means the car will be move either the forward or reverse direction. Second one is for brake and clutch. Nowadays we are using the without clutch, the automatic gearing systems will be used for the advanced gears, advanced cars. So this is the relative velocity concept in the graphical method. A velocity of an object as observed from the another moving object. So this way we have to do the velocity diagram of the relative motion method. So next, this is the graphical method and application two car moving in the opposite directions. We have to do the velocity and acceleration diagram. Visualizing the relative velocity overlay velocity graphs to find the difference. So step by step calculating the relative velocity. Start with the distance time, give the graph of for the two objects, and time calculating the slopes, and find relative velocity means the opposite directions means we have to add these things, and we have to do the velocity speed for velocity method for the same direction mean we have to do the subtraction method. So this is the common pitfalls and tips for accurate the graphical analysis method, slope survey, and distinguish values like average versus instantaneous values, and beware of scale to avoid the distortions in the graph. So build institutions with real data. So this is the summary of mastering motions through the graphs, like interconnected concepts like position, velocity, accelerations by the slopes, and a graph is worth of 1,000 words. We have to do the all this analysis and understanding the relative velocity and acceleration of the either opposite or same direction movement object. And real world insight means we have to apply the methods in the practical problems. So this is the mind map like velocity analysis, acceleration analysis, and we have to use that relative velocity methods to calculate this kind of velocity and acceleration and displacement of the moving vehicles. So in our first in this unit, we have to do the velocity and acceleration analysis for the slider crank mechanism, four bar mechanisms, and different gear trains. So this is the assessment questions from this today's topic. Contact ratio. Contact ratio means the number of pair of the teeth to the contact simultaneously. And next one is for which type of kinematic chain means open chain. And this is the sum of the reference I have to chosen to prepare this materials. And next class we have to discuss about the one more interesting topics which will be related to the turning movement diagrams of two-stroke and four-stroke petrol engines. Okay, thank you.